would look for continuity. The definition of continuity as applied to this problem would be the limit as x approaches 1 of f equals the limit as x approaches 1 from the positive side of f equals f at 1. All three of those components, if I didn't see all three, obviously you don't understand continuity. This, as x approaches 1 from the left, I'm looking at that function, where does that approach? 2. As you approach 1 from the right, where does that approach? Yes, 2. And f at 1 is the same as this guy, which is 2. Because those are all the same, we can conclude f is continuous at x equal 1. Done. Definition of the derivative. If you have this, would you please take a big red pen and scratch that out? That's garbage. That's not the definition of the derivative. I hate seeing that. I'm sick of seeing it. That's not the definition of the derivative. That will not do. Okay, if you have a multiple choice problem and they say, hey, find A and B, so it's different, fine, do that kind of thing. But it says the definition of the derivative. It says show. I expect you to show that you know the definition of the derivative. So something like this. The definition of the derivative, at least the alternate definition, is that. That is one of the three definitions of the derivative. It's the easiest one to work with. You would then say, as x approaches 1 from the left, f of x would be x squared plus 1. We know f at 1 from the previous work is 2 over x minus 1. You could show the next step, or you could just picture it. Wouldn't you have x squared minus 1? And that would factor into x plus 1, x minus 1. X minus 1 would divide away, leaving you with x plus 1, which approaches 2. Now, if you need to show all that factoring and canceling, great. If you don't, that's okay. The limit as x approaches 1 from the right would be using a different f of x. F of x from the right is x plus 1. F at 1 is still 2. It doesn't matter which branch you're doing. When you do f at 1, it is 2, period. Okay? Over x minus 1. What does that simplify to be? 1. Because 2 is not equal to 1, we can say f prime at 1 does not exist. There's a sharp turn. There's a sharp change in slope from 1 to 2, just like that. All right, that's the work I expect you to do. Are you with me? Great. Let's go to logarithmic differentiation. This is a pretty straightforward lesson. Hopefully it will go well. It's a nice little technique for some funky functions. It's kind of been covered already a little bit. When we did y equals 2 to the x, and we found its derivative, what was the technique? What did we do? We took the log of both sides, okay? Natural log. So if you take the natural log of both sides, the beauty of that is that allows you to bring down the exponent. That, to me, is the big idea of not just calculus, but math. If a variable is in the exponent, and you don't want it there, use logs. Okay? Now then, we haven't differentiated yet. We just did some algebra. Okay, so now we need to differentiate with respect to x. If I differentiate with respect to x of both sides, oops. Oh, the colors. X log of 2. What's the derivative with respect to x of log of what? Implicitly. 1 over y. Then the derivative of the inside, there is a chain rule for that. Derivative of the inside is dy dx. The right-hand side is ... what? ln of 2, also known as natural log of 2. Okay? But I like that you're participating. Excellent. Y, dy dx equals y, natural log of 2. At the last, then, we substitute in for y with what it was to begin with. What was y to begin with? 2 to the x. Okay, then. Now that's really, what's new would be something like this. Y equals x to the x, not 2 to the x. It's the same concept. What do you reckon we do if we have a variable in the exponent? You take the log. All right? So, if you get a variable in the exponent, use logarithmic differentiation, which is to say log, then differentiation. The derivative is of the left. What? Mr. Barney, hit me. 1 over y dy dx. On the right-hand side, now we must use what rule? Product rule. What is the derivative on that right-hand side? Jack, hit me.
X times
Wonderful. Okay, so with a little cleanup, a little moving of the y, a little substituting back for the y, our final answer would be something like 1 plus log of x times the y that we bring over, substituted for, which is x to the x. Is that easy or what? All right. You try these. The only gotcha, I would say, is on a problem like this, when there's no other side, for example, make one. In other words, call this, you see what I'm saying? It doesn't have a y equals on that side, and it makes it hard to log both sides when there is no other side. So I would start by saying let y equal u to the cotangent of u, then do your thing. Okay? Sometimes the notation isn't as friendly, you need to work around that. I'll let you do those 4. We'll go over them in a minute. Here's some old stuff. Here's our first page of practice. Oh, here's your homework. Here's from last week. It's groups. Oh, and shoot. How do we do in the first one? Really? I thought it would go well. Let's do it, everybody. Drastically terrible for everybody? Or just moderately terrible? Or not terrible at all? Sarah, how'd you do? You didn't have to call, if you had cosine over sine, that's fine. You didn't have to call cotangent. I'm just overachiever like that. So check your product rule on the right-hand side. Check your pieces, your derivative pieces. And then check the overall log differentiation I did. Let me know if you have a question about where I'm coming from. remember your cotangent derivative? A little bit of review doesn't hurt. There's my second one. See if you agree. Notation-wise, that third one's kind of funky. But I guess I'll just plow ahead like normal. Oh, man. Ooh, that's a tough one. Are you on the third one yet, or are you still working? So that third one's a bit funky. That not everything's going to always be just regurgitate the mindless steps. You have to sometimes think. If I log both sides, then it doesn't really deal with the tangent very well. So what should I do? Arctangent. Yeah, let's do that first. So let's do arctangent of f of x equals x to the 3x squared. Beautiful. Then we will, man, this is going to be a mother. Then we'll log it. And we're talking double chain now on the left-hand side. Ooh, this is a big boy problem. All right, so what about the left-hand side when we differentiate? What's the derivative of the log of arctangent of f of x? 1 over arctangent of f of x. That's the derivative of the outside. Now times the derivative of the inside. What's the derivative of arctangent? 1 over 1 plus f of x quantity squared. But then, chain rule again, times the derivative of the inside of that, which is dy dx. There's no really y here. I would call it f prime. Okay. That's super great. Now the right-hand side is product rule. That actually feels pretty easy now. 3x squared over x, plus 6x natural log of x. You concur with that product rule derivative. Beautiful. F prime at x then is all that stuff. 3x plus 6x natural log of x times the reciprocals of those guys with f replaced. So arctangent of tangent, that'll clean up. Arctangent of tangent of x to the 3x squared, And then what about 1 plus f of x, 1 plus tangent of x to the 3x squared, all squared. Then we would just rewrite this as x to the 3x squared, or tangent of the tangent. That was fun, huh? All right. Try the last one. It's a little softer. Get your confidence back. Yep.
Is it is the tangent of x to 3x and that whole term is squared?
That whole tangent term is squared. I think I wrote it badly. The whole tangent term is squared. Yes.
So it's 1 plus tangent of x to 3x close the parentheses squared.
3x, the x is squared, then the tangent is squared. Let me write it better this way. 1 plus tangent of 3x squared squared. Okay? That is gross. That's better. Okay. This is another one of those you need a second side. So you let y equal. A lot of common errors here, actually. I know I said this is a soft one, but there are a lot of common errors on the 2x. It's not just straight up x anymore. So log of y equals sine of x log of 2x. We? Yeah, that feels okay. All right, so 1 over y dy dx equals sine of x. What's the derivative of log of 2x? 2 over 2x, so actually amounts to 1 over x, right? Plus cosine x log of 2x. Did not get myself enough room. So dy dx is sine of x over x plus cosine of x log of 2x, all of that quantity times the original y, which is 2x to the sine of x. Okay. These are far uglier than you'll see on an AP test, but I want you to be ready for the worst. All right, so that's actually one way to use logs for derivatives. There's another way to take logs for derivatives, and I am most grateful for this. Say you're given this huge, hideous, ugly function. You've got a product, you've got shades, you've got quotients, you've got products within the quotients. Do you agree it's pretty ugly? Yes? Okay, this is slick. Now, if you were to take the derivative of that, you would think, oh, man, that's a stinking mess, right? Well, I'm here to tell you that with a little trick, this can be actually a pretty easy problem. You use logs to blow it up, and then take the derivative. If you take the log of both sides, that is mathematically sound, as long as you're doing it to both sides. Now you might say, why would you do that? It seems like you're taking a complicated problem and making it more complicated. But in fact, you just made your life much easier. The left-hand side can stay log of y, but by log rules, now I'm going to show several steps, but on the homework you're going to condense these a little bit. Wouldn't you say that by log rules, the log of a product is the log of the separate sums? So I could call this log of root x minus 2 plus log of 2x squared plus 1. And anything in the denominator would be a negative log. You follow? Furthermore, any root or exponent could be brought down in front. So for example, I could rewrite this as 1/2 log of plain old x minus 2. Yeah. That was the only one where there was a root applicable or a power applicable. So that's cool. Now, you could definitely do this in one step in the homework. You wouldn't need to do this. Well, that's great, but I just have done algebra so far. I haven't actually taken a derivative yet. So now I take a derivative. Differentiate with respect to x, I get dy dx, so 1 over y dy dx on the left. And on the right, instead of this huge quotient rule, product rule, chain rule mess, it's just some really easy log derivatives. What's the derivative of 1/2 log of x minus 2? 1/2 1 over x minus 2. Okay. What's the derivative of log of 2x squared plus 1? 1 over 2x squared plus 1, then by chain rule, 4x in the top, yeah? The next one, derivative of the log is 4 minus x, derivative of the inside is -1, so that turns positive, yeah? And the last one, derivative of the log is 1 over sine, but the derivative of the inside is cosine. Now, can we write our final answer? It would be all that stuff, 1 over 2 root x minus 2 plus 4x over 2x squared plus 1 plus 1 over 4 minus x minus, let's call it cotangent, times the y, which is, right here. That's nothing big. Now, as ugly as that is, it's still a lot better than using chain rule, quotient rule, product rule, math. All right? Let's try, rather than do another one, let's try doing number 9 on the homework, which is, yikes, y equals, here we go. You do not need to write the original problem if you do not care to. You'll eventually start to put together fewer and fewer steps and do this with less and less work. So that's the problem. The goal is to differentiate. So find you what you got. You're welcome. I'll give you a really long box for these. I should have made it all the way across. Do you agree with something like that? Well, okay. I realize you have questions on 83 as well, but I also want to go over at least a good chunk of that AP review I just got back to you. I remind you, you want to be in about the 2/3 region. So for the multiple choice, you want to be in the 6 to 7 ballpark, and on the free response, you want to be in the 12-ish ballpark or more. Let that just be a sign of where you need to improve. And gotta be honest with you, I wasn't super pleased with the results. They weren't great. We have a long way to go. I'm going to put some of this back on the test on Thursday. So I hope you make your notes and learn from your mistakes. And here we go. So I need to get my key out. Before I do this. Give me 1 minute to get my act together, and then we'll get rolling. Let's see. Okay. The first one I expected it to be a little iffy. It was from set 78, 41 people. This was roughly out of 30, I don't know, some 31, 32 people. There's some people absent. So 21 people missed number 4, so I guess that's a pretty good indication it didn't go well. So let's go over that. I understand that if you say speeding up, that means velocity increasing / acceleration positive. Unfortunately, it doesn't say where is velocity increasing. It says when is it speeding up. And that means not velocity increasing, but speed increasing. And so you do not just look at acceleration. You look at when velocity and acceleration have the same sign. Speed is increasing if velocity and acceleration have the same sign. If you're moving negatively and you are accelerating negatively, or if you're moving positively and you're accelerated positively, you would need to find zeros of both the first and the second derivative and then figure out where they have the same sign. Okay, so let's just, if you were to find velocity, it's y prime. That's 4t cubed minus 36t factored. That's 4t factored out, leaving you a t squared minus 9. The zeros on that are 0, 3, and negative 3. Do you agree? The acceleration is y double. That's 12t squared minus 36. That factored is 12t squared minus 3. That's 0 at root 3 and negative root 3. I personally was taught then to, rather than do one sign chart, you do kind of a super sign chart. You have up to negative 3, then negative root 3, then 0, then root 3, then 3. And I say, what about the signs of velocity and acceleration? Velocity factors that way. You can sign test it, and you look for where they have the same sign. Yes?
You wouldn't have to sign test negative 3 and negative root 3, right? Since the interval is 0 to 5.
Oh, correct. You're right. You would go restrict. They gave you a restriction, so you would only do 0 to root 3 to 3 to 5. Good point. You're right. Thank you. Always use the restriction. I should have circled that. I would usually circle. Okay. So that's not too bad. That gives you 1, 2, 3 regions to test and decide between. 14 was D. Only 7 people missed that, so that went pretty well. I was happy with that. 33 was U sub. I was surprised 11 people missed that. I didn't think that was that hard. The answer is D. 25, for whatever reason I didn't quite get on 25, but I thought it went pretty well. The answer was B. This, I was not super pleased with how this went. This is related rates. How fast is the height of the pile increasing? You're given a lot of stuff here. The height is twice the radius. The sand is being added at. That's dV dt is positive 30 pi. How fast is the height increasing? They want dH dt. when they give you a kind of a convoluted instant, the circumference is 125. Given that circumference is pi d, that would imply diameter is 120 or radius is 60 at the instant. Are you with me? You do not differentiate with respect to three variables if you can help it. The first thing you should have done is use that fact to substitute and get it down to 2. You want dh dt, so you probably want h to stay. You're going to want to sub in for r. So what is r? It's half the height. If you put that in, you get the volume as pi over 12 h cubed. Do your calculus. Okay? There's such a rush to get to the calculus that you make the problem a little bit hell. The expectation is that you do a ton of work up front, then do the calculus so the calculus goes smooth. If you try and differentiate it, you've got to use the product rule. It's a mess. Please, I beg you, get it down to 2 variables if you can. All right. This and a free response is the fundamental theorem. This needs to be rock solid. This has to be awesome. It's all over every calculus test you'll ever see, AP, college, whatever. It's the fundamental theorem of calculus. I mean, the name says it all. G of 0 is the area accumulated from -4 up to 0. That then, if you just put 0 in to the function for G, you're saying what's the area under the curve from -4 to 0? Well, that's a positive triangle and a negative triangle. Do geometric area. The answer is B. The equation of the tangent line, you know you need a point and a slope. The point is 3, G of 3. G of 3 is kind of incomplete. G of 3 is -4 to 3. So you'd have to calculate the area from -4 to 3, which amounts to a positive triangle. You could actually use the answer you just got up to here and then build off of that if you like. Or you could start from scratch. But you need to find the point. Then you need the slope. What is G prime? The slope is G prime at 3. G prime at 3 is equivalent to? It's what's the derivative of the antiderivative, so it's just f at 3. F at 3 is 0. At that point, then, it doesn't really even matter what the point is. You can think that, well, actually, you do need to know the point. Y minus whatever the point is, 0x minus 3, y equals whatever this point is. I think it's y equals 3 or something like that. What's this guy? Okay, and then only 2 people missed 28. That went well. 34. So it's moving along the axis, velocity is negative. What is it farthest left of its starting point? Wouldn't you agree that at point A, velocity is negative, so it's moving left. At point B, velocity is negative, it's still moving left. Point C, its velocity is negative, it's moving left. Point D, is it now moving right? No, it's still moving left. In fact, point E, it's still moved left, so it's moving left this whole time. So when will it be farthest left? At point E, okay? Forget C, I don't care if it sees them, I don't care. It's moving left the whole time, period. And then that was E. You might write yourself a note, moving left the whole time, if you missed that. If you missed this, you just need to organize your work a little better. It's fundamental theorem and rules of integrals. The answer was A. All right, then. This is then what I want to focus on for a couple minutes. If I were to collect all the AP questions for the last 30 years, this is the most common one, and I'm not talking even close. It's probably on their AP exam twice as much as any other question. Guaranteed. Absolute fact. And why this is not a 9 is frustrating to me, because we've done this to death. You've got to be able to kill this. Not, I have a good idea, I got a 6, that's great. No, 9, period. That's it. Okay? So f of negative 6. So the idea is you've got a point, and it's the fundamental theorem of calculus. F of negative 6, you're going to talk area under the curve and the initial condition. Now, it's up to you how you go about this. You could use fundamental theorem of calculus and say f prime from where you know to where you want and work from there. Or you could say starting plus change equals ending position, whichever you prefer. Do you have, those of you that have a clue what I'm even talking about, which one would you like to go about this at? Second, okay. That is definitely, that's how this canon teaches, and it seems to go well for those two, so let's go there. Okay, and I agree that it works fine. So, if you take the starting condition plus the change, then the starting condition is, they tell you f at negative 2. And the change then will be from negative 2 up to whatever x they ask about. Whatever they want. Under the curve. Okay, that will find the f at any x. Starting point plus the area under the curve. After that, you have to be very solid with details. So if I want f of negative 6, that's f of negative 2 plus the change from negative 2 to negative 6. Now, we talked how if this is going from greater to lesser, that's not good. We would like to rearrange this and call this more like the opposite and go from smaller to greater. Are you with me? Are you with me? Okay. Now let's start to substitute. F of negative 2 is 7. Okay. This is area, sine area under the curve is in geometry. Any area that's above the axis will be a positive. Any area that's below the axis will be a negative one. From negative 6 to negative 2 is here. That is a positive area. And we're going to put it in there and find. So we take 7 minus, the base of that triangle is 4. The height is divided by 3. Okay? If I want f at 5, it's f at negative 2 plus the change from negative 2 to 5. F at negative, this doesn't need to be rearranged. It's already going lesser to greater, so we're cool there. F at negative 2 is 7 plus areas from negative 2 to 5. Well, here's negative 2 to 2. That is a half circle, and it is below the axis, so it has to be negative. Then you're going from 2 to 5. That is a triangle, and it is above the axis, so it must be positive. 7 minus pi times 2 squared over 2 plus base of 3, height of 2 over 2, 10 minus 2. It's just the time. We're going to finish going over this tomorrow. Let's go to 80 questions you have on. Bring this tomorrow, please. Questions on 83 if you have any. If you get extra practice on this, I suggest you come in 7th hour. I have 100 problems I could give you. But I guarantee it'll be on the test. 83. 6 and 8. Oh, yes, the answer sheet. That was great. 6, 8, 15 and 25. 15 and 25.
Oh, also,
5. Okay, 5, what'd you say, John?
1525.
15 and 25. Gotcha. Okay, here we go. 6. We're going to print for that. 6. Here we go. Okie dokie. 6, is that replaced or straight up normal? Okay. So first quadrant, e to the x and x equals 3. So here's e to the x. Here's x equals 3. So there's the region in the first quadrant, revolved about the x-axis. So in terms of the calculus technique, I think, actually, do you agree that it's a disk, not a washer? And do you agree that the r is e to the x? The issue is, what about the 2? I would use exponent rules and call it e to the 2x. And then whether you actually use sub this or mental use of this is up to you. You could, if you were to mentally use of this, I would say u is 2x, yeah? So I would love there to be a 2 here, which I could do as long as I balanced with a half out front. Then it would be just the antiderivative of e to the 2x from 0 to. Okay? Now if that idea, that tweaking it to make a good use of doesn't work for you, then really use of it. Just don't forget to change the limits. Okay? 8. 8 is revolved around the y-axis. When you take this region and you revolve it around the y-axis, you must use y as the variable of integration, and you're going to get a washer. Washers are big R squared minus little r squared, and it's dy if it's around y. Big R, wouldn't you say that here's big R, and it's the distance to the line in y terms? And the line y equals x in y terms is just y. Little r is here. Little r is the distance to the square root curve in y terms. So that's y squared. All squared. And the limits are still from 0 to 1. Wait. Does that make sense? Okay. I'll say yes. 15. 15. So this is so different from this. If I had a sum in the numerator, I'd split it. But if it's a sum in the denominator, you can't split it. So this would be u sub. Let u equal x squared minus 1. Oh, no wonder you're not confused. You're not.
It's 3 over 2x squared.
3 over 2x squared plus 7. Got it. Thank you. Okay. So this is an arctangent kind of problem, yeah? I would start by making this 1. So if you factor out a 1/7, I'll also take out the 3 if you don't mind. Call this 1 over. This would be 2/7 x squared plus 1. You would have done that so far? Okay. Now, this then is u squared. If u squared is 2/7 x squared, then u is root 2/7 x. Do you agree? And therefore du is root 2/7 dx. So when I go to make my substitutions, the 3/7 is still there. Dx would become root 7/2 du, which I could pull out front if you like. It's a constant. Then I have my arctangent. So I'm looking at 3/7 root 7/2 arctangent of u, but then I go back and replace u with root 2/7. Make sense? That one's a bit of a mess. All right. 25. This is a good question. The idea is you want to set f prime equal to f over the interval. Make sure I get this by the end of the day, please. So you do something like, that's the basic gist, and then find the x. This is called the mean value theorem. I will be happy to help you in 7th or after school. And have a nice day. You can keep them. Thank you, though.